Hey, how's it going, guys? Here is the propagation model I was talking about. So here's a few of them that I created. I like doing them in 4 watt and 1 watt configurations, that way I can kind of see the difference between the power levels. It just gives me an idea of what my equipment's going to operate like in that terrain. I honestly can't tell you if this is going to transmit all the way from here, this huge distance, but it's likely if you're up at this high elevation, right? You're not going to be able to necessarily hear back here, but you would be able to see the signal break the noise floor, which if you're trying, direction find comms, or if you're trying to, limit your exposure in the EMS, it's good to be cognizant of where your transmissions are going to go. So I like using these because, again, it gives you an idea of how your equipment is going to operate. And then this ring is like necessarily where it stops. It's just where the model stops. That being said, you can come out here, and this would give you an idea too for like planning and actually testing your equipment, because you can say, hey, I want to be at this point, right? I know I can get there, and I know someone can get over here, right? Then you come out here and you can actually test it, right? And be like, okay, let's see how accurate this modeling software really is. So now that I've showed you kind of what it looks like, I'm going to show you how to make them. So to make them, you need an operating system called DragonOS. It's an OS that's just built around SDRs. It's really cool. It does like all the kind of hard work for you of getting all these softwares to work together. And then it just has like a lot of really cool built-in features. So if you're into SDRs and radios, like, I recommend it. I like using it. It's cool. The dude's pretty smart. He has a lot of videos on YouTube and things that you can kind of go down the rabbit hole on. So I'll show you that right now. Alright, so this is DragonOS that I was talking about. So prerequisite for this is you have to download all the data, the elevation data. So that's not hard to do. I'll post a link to his video which shows you how to get all that. It's pretty cool. He goes into more detail also as far as like what I'm talking about. He has other videos and he goes into a little bit more detail. So I'm just going to show you real quick kind of how to get it all started. So after you have elevation data, open up your terminal. Once you're in the directory, just run the signal server GUI. Go to port 8082. Alright, so once you're here, it's going to tell you a little bit about the software, and then some other information about it, kind of how it works and whatnot. So first thing you have to do is you have to create your station. So I just picked a point kind of like before in the mountains. So let's name this one. So Goon plot 1, right? Alright, so once you have your name and your longitude, latitude, then you can come in, and I just leave everything kind of as is. You can really get in the weeds in here and start messing with stuff whenever it comes to plots, like you'll see. So once we come in here, we'll go to plots, we'll go to new, and note real quick for the antennas, you can't add new antennas. We're just going to use a dipole, which is going to be an omnidirectional antenna like you would have on your Bofang. And that should be good enough for this to at least get you started and get you kind of understanding what's going on. And then you can come in, you start researching on these settings and changing things and seeing what it does to your model and whatnot, and really like getting in the weeds and learning a lot. So Goon plot 1 watt, target 430 megahertz. Let's say 1 watt. I like adding in the climate because it kind of adds some real world isms into your model that it can calculate for a little bit. Again, it's not going to be perfect, but understand that things like trees and buildings and water and power lines, all these things are going to affect the way that your radio signals actually move through the air and get to that receiver. So to come down here, I'm just going to pick generic dipole and pick our station that we made, Goon plot 1, Then no need for station 2. That's just if you're going to do a point-to-point. Alright, one thing I wanted to change real quick was whenever you come in here, you can edit it, and I want to change the height to be the average height. So 1.8 meters is, 5 foot, 9 inches, roughly. Make sure everything's good to go still. Come back to plots. Create one. We're going to create one more for 4 watts. So after you create these, you can click on View, go to Files, and here you can kind of get just a generic overlay of what it's going to look like. So once this is done, and that looks somewhat right, come here to KML, download your KMZ files, and then we'll pull them over in Google Earth, and I'll show you what it looks like. Okay, so now that we've created our new model, I went ahead and pulled the 4 watt and the 1 watt into Google Earth. So you can see the difference here. So 1 watt, 4 watt, right? 1 watt, 4 watt. So your transmission will be able to pick up further away, although not audible, but you will still be breaking the noise floor, and you'll still be creating a signature. So something to consider whenever you're operating, right? If you are in this valley with multiple people that you can communicate with, you might not need to use 4 watt, maybe just 1. Maybe if they're kind of pushing the outskirts here of your radio's capabilities, maybe you want to increase the power. Another thing too to consider is this is just at the bottom of this valley right here. If you're coming up, obviously you're going to start radiating this way, right? So maybe it's not the best spot for an OP. Maybe you need to move it. Right, just gives you an idea of how your equipment's going to work. So hope that you guys find this helpful. Like, retweet, whatever. It's my first video, so hope that the information is useful. If not, cool. Let me know what you think. Appreciate it, guys. Have a good night.